Hello, everyone, and thank you for joining this talk. My name is Brandon, and I would like to present our paper entitled Augmented Reality at Zoo Exhibits, a Design Framework for Enhancing the Zoo Experience. Zoos have traditionally been viewed as places for entertainment and leisure, but have evolved into institutions with complex goals that include fostering social interactions, education, conservation, spreading awareness, among other goals. This shift in objectives have not only influenced the ways zoos operate, but also their physical characteristics, evolving from something like this to much more naturalistic exhibits designed to cater for the animal that the exhibits house. These naturalistic exhibits are excellent in showing animal behavior in their natural habitat, but sometimes create challenges that inhibit the zoo's ability to engage visitors. One challenge, for example, is animal visibility, which can disengage visitors with the exhibit and any conservation message that might be related to this exhibit. As you can see, it is quite difficult to find and observe the snow leopard in this case, which could be even more difficult if it was trying to hide. In an effort to find new and exciting ways to engage and educate visitors with broader zoo objectives, zoos have been open to adopting and exploring novel technologies in achieving their goals. For example, as early as 1997, researchers have used VR to enable visitors to experience and learn about gorilla behaviors and their social interactions. There are, of course, challenges to integrating technology into zoos, with prior work expressing concerns related to disruption to animal natural behaviors and also hindering the visitor's visual connection with the animals. Augmented reality possesses unique capabilities that could provide a solution to these challenges. Specifically, AR enables digital content to be superimposed directly onto the real-world view of the users, thus not disrupting the animal's behavior and also allowing the visitor to view both the animal and the digital content. However, integrating AR with zoos come with their own set of challenges. Different exhibits may provide different affordances for AR technology. For example, different lighting conditions can affect the visualization, and different animal vocalization, noise can affect auditory AR content. This is further influenced by the specific zoo goals that the AR application is designed to support. So to better understand and support the design of meaningful AR applications for the zoo, we conducted 2 scoping reviews focusing on existing AR app and broader technology use at zoos, a field trip to a modern zoo with naturalistic exhibits to better understand how naturalistic exhibits affect AR use, and a workshop with zoo representatives to better understand the objectives of the zoo and how they envision the use of AR to help support these objectives. For both our reviews, we searched the ACM Digital Library, the IEEE Explore database, Web of Science database, and Design and Applied Arts Index database. Our first scoping review focused on the current use and design of AR at the zoo. We followed the PRISMA guidelines and included about 11 papers in total. We paid specific attention and extracted details related to the design elements that these applications were focused on. We found 4 themes related to design elements that were the focus of the applications in our sample. The first is location-based content, which focused on applications that focused on where to place AR content, either through GPS or markers. The second set of design elements was game elements, which focused on including mechanics such as solving puzzles, completing challenges, gaining points, leaderboards, and so on. Third theme that we found was social interactions, which leveraged AR's capabilities to keep other individuals and group members in view, and people could still socially interact with them. And the final design element of focus was content and user experience, which focus on the content itself. For example, showing a 3D visualization of the anatomy of an animal, which the users could move around and see from different perspectives. Our second scope and review focused on the use of broader technologies to enhance the zoo experience. We focused on design elements again, but limiting it to design elements that were within the capabilities of AR. We've also again followed the PRISMA guidelines and included a total of 50 papers. We found similar design elements, such as game elements and social elements. We found certain design elements that were an extension of the design elements found in our previous review, which was scope, which extended the location-based content design element, and content type, which included auditory content and other visual content such as video, which extends the content and user experience design element from our previous review. We also find completely new design elements that were a focus of these papers, specifically perspective, which looked at how to show visitors the world from the perspective of an animal, interactivity, which focus on the different types of interactions that visitors could use to interact with digital content, such as using a Microsoft Connect to interact with digital content, and visual focus, which focused on, or rather, which was designed around where the visual focus of the visitor was, either on the technology, the digital content, or the real animal and their exhibit. Looking at these side by side, we can see that AR, represented by the orange circle, and technology use at the zoo, represented by the blue circle, there is a bit of difference, and we can see that few design elements were not really explored by the AR technology in zoos. While these reviews gives us insights about the potential that researchers and technologists see in the use of AR and technology in zoos, we wanted to get a better grasp of the challenges and opportunities that zoo stakeholders saw in the use of AR technology. Therefore, we conducted a workshop and invited stakeholders to participate in our workshop. These stakeholders included members in charge of digital engagement, education, business application, and visitor experience at zoos. We first introduced them to AR technology, in this case the Snap Spectacles 2021, along with a number of different applications to showcase the capabilities of AR, such as hand tracking, object registration in the real world, and we also showed them videos of other forms of AR technology, such as the HoloLens 2. We then conducted our workshop where we asked participants to reflect on current challenges in the zoo and the opportunities for AR use in zoos, and then to ideate on concrete ways of using AR to achieve zoo objectives. Participants came up with a number of challenges, opportunities, and ways to integrate AR for zoos. A large portion of these were shared resemblance to the work done in prior work that we found in our reviews, but some related to conservation and environments were fairly new. However, these were more fitting, at least during the ideation phase, these were more fitting of virtual reality as opposed to augmented reality. For example, one idea was to enable visitors to view a marine animal rescue mission from the perspective of the rescuer, which again is more feasible using virtual reality rather than augmented reality. Finally, we conducted a field trip to Melbourne Zoo and used the Snap Spectacles in situ to better understand the challenges and opportunities of using AR application in zoo exhibits. We were accompanied by a specialist in animal welfare who had extensive knowledge of the zoo and who had worked in the zoo for many years. We asked the specialist to guide us through the exhibits with distinct characteristics to enable us to gather insights and observations about the effects of different characteristics on AR technology use. We collected about 21 pages of observation notes and 80 exhibit photographs. We found both physical and contextual characteristics affected AR use. Physical characteristics included lighting, viewing area size, exhibit barriers, and contextual characteristics included things like noise, crowd density, animal behavior. Viewing area size, for example, affected how much interaction was available to the user. So if we wanted to create something with to work with a small viewing area size, we couldn't allow a lot of interactions in our applications. Based on our findings from the scoping review and workshops and field trip, we developed a framework to support the design of meaningful AR applications to enhance the zoo experience. The framework consists of 3 stages: figuring out the application goals, figuring out the exhibit affordances, and deciding on design elements. Each stage consisted of 2 activities, and each activity was concerned with 3 different elements. To better understand and describe the use of our framework, I will use the help of an example, and the example we'll be using is to educate visitors about animal behaviors and physiology. This is something that came up in our workshop as well. Specifically, we will be looking at educating visitors about pit organs. Now, pit organs are specialized organs that certain snake species have that help them detect heat from their prey. specifically mostly rodents and nocturnal creatures when it's already cool outside and the heat can be sensed. Since we already have an objective, in this case to educate visitors, that we start from the application goal stage of our framework. We won't be too concerned about enhancing the experience or providing novel experiences. Next, we look at the targets. In this case, we want to target individual visitors. We have a selection of the zoo subject. We can look at either the snake species with pit organs or the prey species. For this example, we'll use the prey species of a rodent, and we're looking at visitors that actually come into the zoo. So they would be using this application in situ rather than remote visitors. We next jump into trying to figure out the exhibit affordances. Since we're looking at the rodent, which is nocturnal, they have usually dimly lit exhibits. The exhibit barriers for smaller species are typically have glass barriers. And because it's a small animal and the exhibit is fairly small, the viewing area is also small. Contextual characteristics, we can assume because the animal is usually very shy and difficult to spot because it hides a lot, crowd density is low. It's not a vocal animal, and since the crowd density is low, the noise is also low. And the animal behavior, because it's shy, makes them less visible. Finally, we look at design elements. Given all the insights already drawn, we know that we're looking at a small exhibit with a small viewing area size, so we want less physical actions. We could include social interactions, but we consider only small groups because the crowd density is low, so there might not be enough people in there for social interactions. In terms of visual focus, we can create digital content that visitors can focus on because the animal is usually hiding anyway, or we can help visitors try and find the actual animal within the exhibit. We can present both implicit and explicit content. Explicit can be an audio that explains how snakes find and capture their prey, or implicit could be allowing visitors to take on the perspective of these snakes and have heat vision, so to speak. Because the noise was low and also the animal hides a lot, we can include audio, video, 3D visuals, or any type of content. Given these restrictions and affordances realized through our activities, we could design an application that enables visitors to view a 3D virtual model of the rodent, for example, from different perspectives. We can enable them to change perspectives from human to snake vision or heat vision with minimal interactivity. An illustration of that is presented here. These design adheres to the findings of the framework, which calls for minimal actions on account of the small space and allows for visual content that visitors can focus on. Alternatively, if we want visitors to try and find the rodents within the exhibit, we can employ animal detection techniques, either with the help of cameras within the exhibit or potential animal detection techniques that can tell the AR device where the rodent is within a digital twin of the cage, for example. We can then employ design elements where the focus is on the animal, in this case trying to find the animal. We can enable an interactive 3D visual filter that puts a heat vision filter on the detected animal that gives a simulation of what the snake's perspective is. We can have minimal interactivity, again, just a button to switch between snake and visual. We can also include game elements and social elements where people play against each other to try and find as many rodents or find the rodent as quickly as possible. An illustration of that is given here, and we also elaborate on this on the paper. Finally, we demonstrate the use of our framework using a prototype for multiple language accessibility and support. In conclusion, we have developed a design framework underpinned by 2 scoping reviews, workshop, and a field trip, and we demonstrate the use of our framework using an illustrative example and a prototype. We think that our framework can also be of help to AR developers and designers in other domains other than zoos, such as those in tourism and cultural heritage sites. Thank you.